exhibition where they say they can be much more faster with these chips. So why is the delay bigger?
Why is it delayed?
Yeah.
Becoming
Why do we have a higher gate delay with newer chips? I do not believe this.
Yeah. Okay. Dear Hochkiller opponent, thanks a lot. First of all, it's a wires which is you're going to going at wide level, and I've worked on a bit higher abstraction level. But what I feel is that why hardware clock is there. The reason is that the clock frequencies actually you increase, the wires becomes more global sometimes, and then it's really hard for them because it's spanning more in the chip. So it becomes really hard to actually do it one cycle. So one of the reasons is that they become more global, they become like more in size. So it's very difficult. And there are some equations, I don't know, but I forgot, but I think by shrinking there's actually resistance increase in something, and then they actually produce some resistance to the traffic or the signals. But the main idea of the hard knock is like, why is one way of looking at the hard knock? When we see, what we see is that hard knock is an inter-IP communication architecture. We see the communication between the IPs is coarse-grained. It's not a bit level or just a one wire or two wire levels. It's a coarse-grained level, 32 bits, 64 bits, pixel level, 9 bits. So it's like you just want to have wires which can transport the data. When we use the current FPGA architectures, they are bit level reconfigurable. At times you can configure them to a certain extent. So let's say I have one node, two nodes, I want to transport one data from here to there. If I have the wires of same length, I can be sure. But if I'm not sure, because this is the case with the FPGAs, because they can try, but they cannot give you 100% guarantees that from one node to a node you will all the wires of the same length, and then they can give you the authenticity. That's not possible. By having a hardware knock, what you get a design time architecture that is pre-verified in terms of electrical characteristics. You know that if I transport the data one unit, one node to another, I'll have that much delay. And the wires will be of same length. So I mean to say that this is one idea behind this. So the wires are like very low down, which obviously is not the purpose or the target of this. But if we look down upon how the communication architecture is currently implemented on FPGA and what is our architecture is what we are proposing, we can say that by having hard knock, we have such an architecture, we can give you predefined characteristics in terms of delays.
I fully agree to this. So did you investigate also with the results which we had in a new project called Morpheus? In Morpheus, the chip was developed where we had different reconfigurable hardware units connected over a network on chip. Did you hear something about
Morpheus?
Morpheus, the Morpheus.
I think Morpheus, I read some time before, I think it's a coarse-grained architecture.
It's a mixed grain architecture,
mixed grain.
I would say, because you have fine grain.
Okay, I think when I was reading, so I went through lots of coarse-grained architecture like raw, cold machine, plastic cell, and this one as well, I believe. And but at this point in time, I don't remember exactly what Morpheus was about.
No, this is no worries. Maybe it's of interest. So it was a mixed-grain reconfigurable architecture connected by a network on chip, and the network on chip was a spider network on chip. This brings me to the next question.
Is it a question with a brief answer?
Yes. So you fix your network on chip on your hardware architecture. What happens if someday you want to change it? So you will lose a lot of flexibility if you fix on your hardware architecture the network on chip. So what do you choose? So you choose one hardware architecture now. What happens if one day you want to change this?
Okay. Dear Aqeel opponent, thanks for the question. Obviously, if you are hardwiring something, so you have to pay some cost. But what you're gaining, you have to look down upon at these as well. I will not talk about hardware knock right now. I will say that FPGAs vendor hardwiring something. They are hardwiring the back units. They are hardwiring DSP slices. The same thing could apply to them as well. because they can come up with some more flexible Mac units by using the FPGA reconfigurable resources. They might come up with, okay, the same question could be put to them, okay, one day we don't want to use those Mac units, what would be the cost? So I mean to say, hardwiring has some cost, but obviously some benefits, unparalleled benefits if they're used efficiently, if they actually used in a domain-specific point of view. Let's say I want to have a domain-specific FPGA for video applications. I know beforehand, before selling the FPGA, I will tell the guys, this is the FPGA which is going to be used for the domain video applications. Hardware lock is meant for this kind of applications. Now the rest would be to how efficiently you can map that application onto it. I'm not just talking about the rest of the benefits which we get. I'm just telling that by having just marketing these things in a way, we can easily target larger audience and in a very efficient way.
Okay, thank you.
Does this answer the question, question 3?
Yes.
Yeah. Okay, thank you, Professor Hübner. I would like to proceed with the opposition by giving the floor to Professor Strooband.
Thank you, Research. Waarde promovendus, I read your thesis with great interest, even though I didn't see the nice pictures you put in front on my PDF screen yet. But what I appreciated most in the text was that you have a combination of very different things. You have the hardwired network on chip together with the programming of the FPGA itself and the reconfiguration possibilities, and also the tools and tests for all that. So bringing all this together, I think, is a very interesting thing. But I mainly had a question on what is the main driver for this work is the network on chip itself, the hardwired network on chip. And for this, I think your proposition 3 basically looks into that aspect a little bit. So I have a question on proposition 3.
So, Professor, could you read that proposition out loud?
Yes. If the trade is data transport, a hardware network on chip is the master, not the jack of all trades.
Waarde promovendus, I have a little bit of a problem understanding the proposition, so maybe you can explain me first what you meant by it.
Yeah. Dear co-cleared opponent, thanks a lot for the question. Yes, when I was writing and thinking of this proposition, I had in my mind that I have proposed such a hardware network on chip for FPGA though. So it has the benefits which a hardware architecture can have in opposition to the soft thing. For example, it has lesser area, it has a higher speed, we can have less power as well. We can place the IPs with more freedom. We can place lots of IPs as well. But these are the benefits which we can get when we do something hardwiring of